Just 1 minute. दोस्तों नमस्कार, मैं हूं आपका दोस्त, आपका होस्ट पुनीत भटनागर। और आज मुझे बहुत खुशी है कि हमारे साथ गेसु संवाद के इस मंच पर जुड़े हैं श्री अतुल वर्मा सर, जो 1982 के मैकेनिकल के पास आउट हैं गेसु से, और साथ ही DRDO के बहुत वरिष्ठ वैज्ञानिक रहे हैं। और आज उनके साथ हम बहुत सारी बातें करेंगे, आपको बहुत कुछ सीखने को मिलेगा। लेकिन उसके पहले अतुल वर्मा सर, आपका बहुत बहुत स्वागत।
धन्यवाद। नमस्कार पुनीत जी, और नमस्कार मेरे सभी listeners, viewers, and thank you Puneet ji that you have given me opportunity on this wonderful prestigious platform. So I'm very happy to be with you. I'm sorry that we have been trying to meet for quite long time.
Yeah.
But it could not happen. I am really very sorry for that. But today is the day.
Yeah, today is the day. दोस्तों, मैं एक चीज और कहना चाहता हूँ कि जैसा कि सर ने बताया, काफी लंबे समय से, मेरा ख्याल है करीब 1 या 2 साल से
यस,
हम कोशिश कर रहे हैं।
मैं रिटायर नहीं हुआ था, अभी रिटायर हो गया उस बीच में।
तो मैं दोस्तों को यही बताना चाहता हूँ कि DRDO, इसरो और हमारे बाकी जो डिफेंस की इंस्टीट्यूशंस हैं, वो लोग जनरली किसी भी प्लेटफॉर्म पर जाकर बात करते नहीं हैं। और सर अब थोड़ा सा फुर्सत में आए हैं और ऑफिशियल बंदरों से छूटे हैं और उन्होंने तुरंत एक बार फिर आमंत्रण स्वीकार किया। तो सर आपका बहुत बहुत स्वागत है। हम समझते हैं वो बंदिशें क्या है, हम समझते हैं,
right.
और उससे कोई फर्क नहीं पड़ता सर, क्योंकि आपका जो अनुभव है वो आपके साथ है। तो आज बात की शुरुआत करें।
Oh, sure. Thank you.
ओके। तो सर सबसे पहले ये बताइए कि आपने बड़े बड़े काम किए, मतलब DRDO में जो आपका काम है, जो नाग मिसाइल पे आपने काम किया है, अग्नि पे काम किया है, और दूसरे बहुत बड़े बड़े प्रोजेक्ट्स हैं जिनके बारे में हम अखबारों में, मैगजीन्स में सुनते हैं, जिनके बारे में हर भारतीय गर्व से बात करता है। आपने वो बनते देखा नहीं, आपने वो बनाए। आई थिंक फर्स्ट ऑफ ऑल हम पूरे गेसु परिवार की तरफ से आपको एक बड़ा सा सलाम भेजते हैं, और आपके सब साथियों को जो आपके साथ इस मुहिम में जुड़े हुए, उन सबका अभिवादन करते हैं। लेकिन सर वो मिसाइल जो हवा में उड़ती है, वो कहीं से तो शुरू होती है। तो जानना ये चाहेंगे कि आपकी शुरुआत कहाँ से हुई, आपका बचपन कैसा था, क्या उसमें वैज्ञानिक बनने के कोई बीज थे? मैं जानना ये चाहता हूँ कि जो गेसु के आपके दोस्त भी नहीं जानते होंगे, कुछ ऐसी बातें अगर हमको पता चले आपके बारे में।
Actually, I'm born and brought up in Bhopal.
Okay.
Basically, it was a joint family, and both my parents, father and mother, were teachers. Father is still there, mother is no more. Both retired. And my grandfather was actually he was in service of the Nawab of Bhopal.
Oh.
So his work was, those days Nawabs used to have hockey teams.
Okay.
Then his work was only to play as a center forward player.
Okay.
But it so happened after the independence, all those things over, he got job based upon his minimum whatever qualification, and he pulled on. We also grew up and moved on. And basically my schooling was done in a public school. And then secondary education at government Jangiriya Higher Secondary School near Moti Masjid. That is a very, it was a very famous school those days. Nowadays, I think government schools are not very in the limelight. After that, being a Meritus student, directly I got admission in engineering.
Okay.
So I got first Ujjain. In fact, I was preferring Bhopal or Indore. But my father was more happy that you are in Ujjain, Mahakal ki nagari.
अच्छा,
He
क्या
was a
बात है।
Shiva Bhakt.
हाँ।
So Bhopal, actually, I was selected for architecture.
अच्छा, okay, हाँ।
So some of my father's friends suggested, no, let him not go for architecture, let him go for engineering only. That's where my life was led. Somehow I got transfer for Indore, but then I actually cancelled it. By that time, actually, I was settled in hostel with friends. So that was my early time.
तो हॉस्टल में आपका रूममेट कौन थे सर?
हॉस्टल में मेरे रूममेट सुशील कुमार राठौर.
अच्छा.
Who was president of the retired as a president of GECU Cement, and now he has taken up a assignment in a famous company in Sri Lanka.
Okay.
He has been my roommate, batchmate throughout my, college career. In fact, once upon a time, so happened college hostel was closed due to some चलता रहता है college में. So we moved out and we lived in a small room also together.
अच्छा, क्या बात है। तो सर आप दोनों दोस्त आज जिंदगी में इतने आगे हो।
Yeah.
उस जमाने में उस छोटे से हॉस्टल के उस छोटे से रूम में शायद कभी सोचा ना हो। तो कॉलेज में कोई सी आपकी यादें हैं जो बहुत मेमोरेबल हैं, या कॉलेज का क्या इम्पैक्ट आपके ऊपर रहा?
Ujjain Engineering College, those days, it was not very new, not very old also. And but it had very full, very good, what you call faculty.
Yeah.
And especially maths, physics, chemistry, which are the backbone of engineering. And subsequently, I chose mechanical. So that time, Dr. A.C. Rao. His actually he was the head of the mechanical department, and he has been actually felicitated as one of the international member of some society.
Yeah.
So that was the level of our faculty.
Yeah, I know. Sir, mechanical faculty was even at our time was fantastic.
And
और यहाँ पे जो स्टूडेंट्स लोग सुन रहे हैं उनके लिए मैं बोलूँ कि सर ने एक बहुत इंपॉर्टेंट बात बोली, फिजिक्स, मैथमेटिक्स, केमिस्ट्री विच आर द बैकबोन ऑफ इंजीनियरिंग। क्योंकि जब इंजीनियरिंग कॉलेज में आते हैं ना तो स्टूडेंट सोचते हैं कि अब ये मैथमेटिक्स और ये सब तो छूट गया, अब हम इंजीनियर बन गए। बट आई थिंक दैट्स वेरी इंपॉर्टेंट थिंग दैट यू
no, mathematics goes up to 4th year.
Yeah.
So it's very important.
तो सर ऑब्वियसली वहाँ पे बहुत कुछ हुआ होगा, बहुत कुछ सीखा, और जब आपके इतने अच्छे रूममेट थे तो ऑब्वियसली सबका दोस्तों का फर्क पड़ता है। आपके वक्त में जहाँ तक मैं समझता हूँ पीटी नहीं होती थी, डायरेक्ट सिलेक्शन होता था।
डायरेक्ट सिलेक्शन होता था,
है ना। और रैगिंग वगैरह की बात हम करेंगे नहीं क्योंकि कई बार हो चुकी है, और हम मान के चलते हैं कि हुई होगी, है ना।
Yes. No, my batch was the batch. I will just add a small thing. My batch was the batch which was admitted after the emergency.
Oh, yeah.
So some of our prominent leaders were jailed into the Misa.
I know.
So ragging was on its peak that time.
Okay.
But we learned a lot from that also.
Okay.
They made us disciplined.
Yeah.
And especially हमारे university president Sule साहब थे.
हाँ सर, गौतम सुले जी।
They used to help us a lot. All seniors used to help us a lot.
Sure. तो सर आप मुझे ये बताइए कि उस वक्त में कुछ कैंपस वगैरह तो होते नहीं थे, कॉलेज कैंपस में इंटरव्यूज वगैरह तो नहीं होते थे?
Yeah, those days there was no such thing of the campus. And not only in I think government engineering college, even regional engineering college, there was no such thing. We just take the degree, pass out, come out, and at our own.
तो फिर आप DRDO तक कैसे पहुंचे जरा बताइए.
After that, I started my career in a private industry.
Okay.
Actually, I passed out my engineering at the age of 20. So I was, quite young. My father used to say that have gained some working experience, this, that, and there is no need to, hurry. There is no hurry for earning. So being in Bhopal, I worked in a private industry, which were ancillaries to BHEL in fabrication. There, we did a very good job by fabricating oil mast structures for offshore and onshore both. Based upon that experience, I switched over to Parmaliwales, which was the very first industry in India in composites in Bhopal. And based upon that experience, I got admission in MTech in Bhopal. So I did MTech. Meanwhile, I kept appearing for so many interviews and this thing. I was selected for National Fertilizer Limited, Coal India, Premier Automobiles, and this DRDO also.
Okay.
So actually, my father was very keen to send me into the army.
Acha.
And not only that, we are three brothers. He has put me into the NCC Army wing. Younger brother is in the Air Force wing, and youngest brother is in the Navy. We all passed out NCC C certificates. So, but finally, I was not very keen. I used to tell him that I am interested in defense, but something like different R&D like that. So that way, I got the opportunity, and then I never thought of looking back. I joined.
तो you joined. तो आपने वो पूरा किया, आपका MTech पूरा किया था या उसके
पहले? Yes, I did it. By the time I got this job, only desertion was left. So I took a little extension for the joining, 2-3 months, and then I completed and joined.
तो सर ये बड़ा इम्पोर्टेंट है यहाँ समझना कि DRDO का उस वक्त इतना कोई नाम नहीं था, इतने लोग तो जानते भी नहीं होंगे DRDO के बारे में.
Yeah, even I was not knowing.
अच्छा.
And I was also not aware. And just I came and joined.
Okay. And it was a great opportunity because DRDO ने जो आज किया है हिंदुस्तान के लिए, मतलब वो तो अमेजिंग है सर. तो जब DRDO की बात आती है तब सबसे पहला सवाल जो मेरे दिमाग में आता है वो यही है कि कलाम साहब मिले थे क्या आपको?
Luckily, I was posted to Defense Research and Development Lab, Hyderabad. This is actually one of the most premium institute of the DRDO. And Dr. Kalam was the director that time.
क्या बात है. तो मतलब उनका जो ट्रेनिंग इंस्टीट्यूट था उसके डायरेक्टर थे?
Not training institute. He was the director of the DRDO.
DRDO. Okay.
And later on, I came to know that actually it was he was intentionally brought from ISRO to here. And that time, our Prime Minister, Mrs. Gandhi, she coined a IGMDP program. And especially brought Dr. Kalam here to lead this program. And she gave the assurance that whatever you want, you will be given. So under that, the recruitment drive of the young scientists started. Then I got an opportunity to work with Dr. Kalam. Of course, those days, Dr. Kalam was not a big name. He became the big name afterwards.
Yeah, that's correct. क्योंकि जो आप बोल रहे हो मिसेस गांधी की जो बात बोल रहे हो, हमने वो फिक्शनल तौर पे हमने रॉकेट बॉयज में वो सब देखा है कि किस तरह से टॉप लीडरशिप ने हमारे साइंटिस्ट को लगातार हेल्प किया, उनको encourage किया. And there we also saw Dr. Kalam as a very young guy who was looking up to all these scientists. And so obviously, but I think he was a visionary from the beginning. He had that thing. हम सब लोग तो ख्वाब देखते थे कि कभी उनसे मिलेंगे, पर आपने उनके साथ काम किया है, तो मे बी अगर आप उसके ऊपर आगे चलकर इस चर्चा में अगर कुछ रोशनी डालेंगे कि उनके साथ का अनुभव कैसा रहा, तो अच्छा लगेगा. लेकिन उसके पहले मैं आपसे ये जानना चाहता हूँ कि सर, बात आपके बारे में, हमारे अपने अतुल वर्मा सर के बारे में, तो मैं जानना चाहता हूँ कि DRDO में क्या आपने सीखा शुरुआती दौर में, क्योंकि मुझे हमेशा ऐसा लगता है कि जो पहला जॉब होता है या जो पहली जो शुरुआत होती है किसी भी करियर में, वो बहुत इंपॉर्टेंट होती है, वो नींव बन जाती है. तो कुछ ऐसी चीजें बताइए जो आपने सीखी और जो आपको आपके वर्क कल्चर में शामिल हो गई.
Those days, actually, the IGMDP program was going on. And since I did my MTech in thermal engineering, so Dr. Kalam saw it that thermal engineering directly applicable to heat. Heat means Agni. And he posted me to the project Agni.
Acha, okay.
And there I met another noble person, project director, Shri R.N. Agrawal. And he is still there, and he lives very nearby to me. And he put me in the certain specific jobs of the integration, design, planning, integration testing, launch, moving to the launch, going for the launch campaign. So all that work he assigned to me. And he attached me to that team.
तो हम अग्नि मिसाइल की बात करें.
Yes. So from there my journey started.
So you got a good boss who understood your inherent strength, जो थर्मल इंजीनियरिंग का आपका था, और जो आपको उससे रिलेटेड प्रोजेक्ट में जोड़ा. और उस जमाने में मेरे ख्याल से अगेन दीज आर वेरी इनिशियल इयर्स. भारत मिसाइल के क्षेत्र में कोई बहुत आगे तो नहीं था उस वक्त.
No, those days we still were importing the missiles. Now it has come to almost zero. But those days we were importing the missiles. And that's why
तो शायद हम एक्सपोर्ट भी करते हैं.
Now we are exporting, yes. Now we are exporting. We have recently started export. You might have heard that BrahMos has been the first export to the Singapore, Philippines or some country.
तो सर वो दौर कैसा रहा होगा जबकि आपको सब कुछ स्क्रैच से बनाना है, वो लर्निंग कैसी थी उसके बारे में कुछ बताएंगे हमको, क्योंकि हम सब ने किस्से सुने हैं कि बहुत कांस्टेंट के बीच में हमारे साइंटिस्ट काम करते थे. वो सब फोटो देखे हमने जिसमें कलाम साहब साइकिल के पीछे कुछ इक्विपमेंट लेके जाते थे. तो मैं आपसे जानना चाह रहा हूँ कि क्या कांस्टेंट रहे होंगे जिसके बीच में आपने वो ब्रेक थ्रू काम किया.
We had a lot of constants like this. We didn't have this technology here.
Okay.
Technology in the sense like certain parts or equipments which are used in the missiles or aerospace vehicles, like connectors, electrical connectors, some of the chips. Of course, those are available in open market. So initially we could get them. Slowly we developed our own industry. We moved, we took the private industry and public sectors along with in our program. That was the strategy which Dr. Kalam took. Like involve public sector, private sector, local industries, whatever work they can do in the development itself, so that what they are developing today, they only will start producing tomorrow. And this is one constant that industry was not there, but that we were focusing on developing them parallelly. So whomsoever was interested, we came along with. And there were constants like nobody will give you this technology.
Yeah.
So, and we have to do our work peacefully till we achieve. That's why there is no till that time there was no news or propaganda like that कि भाई ये काम हो रहा है वो हो रहा है.
Yeah, it must be all done very secretly, especially because Pokhran was done in 75 and the international sentiments were against us in a way.
After that, they have put a lot of embargoes.
Yeah.
So those embargoes continued, and we worked under those that environment of embargoes. So we designed our own things, our own components, our own airframe, our own engine, our own propellant, then navigation sensors, onboard computers, electronics, electrical systems, then
everything.
yeah, everything put together them, then test it, and test it not only just once. The minimum testing standards were followed as per the international standards. That minimum 3 times the thing has to be continuously work. Then only it will be used to the onboard application. So it took some time initially, but we could make it.
Oh, that's fantastic. That's fantastic. And also, I think it was not just about making the missile, it was also about making the organization which can make more missiles and
Yeah,
other
it
stuff.
is, parallelly you have to create an infrastructure. See, like infrastructure for testing is very big thing. You have to have test beds for carrying out the testing of the motors. See, like Agni is around 15-ton vehicle. Those days, the first technology demonstration vehicle, and its first stage rocket was 10-ton rocket.
Oh.
And the second stage was another 3-4 ton, like that. Then the payload and like that. So both the engines, means the second stage was liquid engine and first stage was solid. So they have to be tested separately on the test bed. So we created our own test bed also.
Okay. So it's like working like an entrepreneur, creating everything, and all that in certain secrecy. So it was not like you can go and float a tender and say we need this, we need this, we need this.
No, that was also there to involve the industry and other things. But see, by the time I joined, DRDO was having a network of around 40 laboratories.
Okay.
And all the laboratories in the DRDO are assigned a specific task. Say like ours is missiles. Like similarly, there is another laboratory in the Pune which works on the arms and ammunitions. So we took what Dr. Kalam did. He harnessed the efforts of all the laboratories together.
Okay.
And wherever possible, with the shortest time, create the infrastructure. So like one side, the infrastructure is coming up for the testing. Another side, the motor, the component hardware itself is coming up. It is designed, its prototype is fabricated, then fuel is filled, then nozzle is fitted, everything. So like that, then another team moves it to the launch pad. So like then parallel teams were working. Concurrent engineering was the approach which was adopted. And harnessing the efforts of whatever facilities, know-how available in the country, not only in DRDO, involving even private and public sectors also. In fact, some of the private sectors have come up by this time. They are doing themselves independent projects for the DRDO. And it is latest today's news only that DRDO now first time has awarded 7 projects to private sectors rather than giving it to their own laboratories.
Yeah, so the work that you all people were doing was not just about making DRDO. It was basically creating an infrastructure for the
Infrastructure in the
country.
That was the vision Dr. Kalam had.
And that's fantastic, sir. When I'm thinking about it, in those days,
Yeah.
And when we are saying in those days, even Indian private sector was not that that big. They were all working under narrow dimensions, under certain constants.
Yeah, there were certain industries like if you call about the big industries like Tata and Talco, which is in Pune, they make the trucks and all that, and the mobile platforms. We involved them in development and production of the launchers.
Okay.
So that way the efforts were harnessed.
Yeah, so it's fantastic. So what I'm learning today is also the thought process of Dr. Kalam while I'm talking to you, and I think that is the kind of vision. That's why he is so respected. When we say Dr. Kalam,
similarly, another example like Godrej Boysen Manufacturing Company in their Bombay itself, they got a very good machinery setup. So they were involved in the fabrication of the airframe. So like that, and by then actually our local industries in Hyderabad, even small MSME or small scale industries, they were also involved in fabrication and this thing. Now some of them have come to a stage they are collaborating with the defense, and they are taking up the independent task.
Hello.
Yeah.
So sir, that's fantastic. And so Agni pe aapne kaam kiya. But tell me, there must be many failures because when you are working in those kind of circumstances, did it succeed?
No.
Initially.
There were certain failures also. What happened, I recall that is the first successful launch of the Agni technology demonstration vehicle was done on the 22nd May 1989. But this could happen after that, after we all, a team of around 300 scientists were there on the launch pad for about 3 months.
Oh.
And in that 3 months, we moved the missile to the launch pad third time. And third time only it could be successfully launched. Okay. Earlier 2 launches were failures. But the failure was like this. We could abort the mission and we could save the hardware.
Okay.
So like first time because of some technical glitch, battery there are some internal batteries in the missiles which drained out.
Okay.
So we see then that also is an exercise. A live missile which is standing on the launch pad, you have to neutralize it first. Make it horizontal, put it on the mobile launcher, bring back to the shed, and then disintegrate. Take out the batteries, replace the batteries, and then what happens? Once the missile is sealed, the sealed missile opening itself is another procedure. So we learned that also.
And it's very dangerous, I feel.
Yeah. So we took some risk. We learned a lot in that journey. So that was first abort of the mission. Second abort of the mission, what happened? It's another technical one. In the first stage, there used to be, first stage is a solid propellant motor with a nozzle, with a fixed nozzle. Now the technology has come is the mobile nozzle, that is flexible nozzle. But those days that was the fixed nozzle, and to maneuver the missile during the first stage journey itself, you require some side force to be created. That side force is created by a system called reaction control system. And that reaction control system works like this. There will be a secondary fluid stored in the system. It is called strontium perchloride. So that will be injected into the flame of the missile. Then flame will get diverted. So missile gets tilted.
Okay. So that is how it
Correct.
goes. Okay.
But what happened during the launch countdown, there was a technical glitch and that system failed. And that is called SITVC, Secondary Injection Thrust Vector Control System. It's one of the actuator or this thing gave away and that fluid was dumped out. So means for onward application, there was no fluid. Again, we did the same exercise. So this was actually, Dr. Kalam's continuous pressing, and that he himself was there on the launch pad for 3 months without missing a single day.
Okay.
He said, we'll keep doing until we do it. And third time, we could successfully launch. So we learned a lot from our failures also.
I just want to kind of, yeah. So one is technical learning, sir, but how you manage your emotions those times, because failed, and it's all in the news that it didn't happen, our scientists couldn't do it.
Probably it was kept a secret and it has not come into the news.
Okay.
First two awards or might have come, we might have not noticed. But yes, emotions will be there. Every person at different age group will have different kind of emotions. Some are away from the families. So we have to, bind together and keep it intact, the things under the guidance of our seniors and leaders. And when they are there along with us, they themselves are sitting, showing their zeal and hard work, then we also follow.
Great. So this is Agni, which is like Earth to Earth missile.
Agni is surface to surface,
surface
to surface ICBM, intercontinental ballistic missile.
But you also worked on underwater missiles, I heard.
Yeah. After that, the work continued. Then Agni teams were enlarged, and then there was another requirement came. Almost secret project was there for underwater missile those days, and what happens actually, underwater missiles have to be launched from underwater submarines. And these submarine and missiles are designed for each other. They have to marry.
Okay.
So during the planning and the design stage itself, you have to plan how many missiles you will keep on a submarine, what will be its dimensions. So what should be the dimension of the submarine? Then what will be the optimum size of the missile? Then what is the range you want? Then how to equip inside the missile? Then how to test it? Then testing of this kind of missile itself is a challenge. And this technology was not available. And it is non-transferable to any country. As per that missile, some international treaties. So we developed our own systems, static platforms to do the testing, Meanwhile, and I was associated, fortunately, for this project right from the scratch, ab initio. I did part of the design, planning, preparation of the drawings, components fabrication, testing of the whole system, testing of the full system, and then integration testing. And then finally, it went through a number of tests, around 16 tests it has gone through to prove the entire product
Sir, there are
before
some questions.
user.
There are
So
so many
then
questions.
challenge started that production planning, then training to the user, deployment, and
And you were involved in the whole process.
yeah, I was lucky to be part of the entire gamut of it.
क्या बात है, क्या बात है. Sir, there are so many questions in my mind. So first of all, what do you mean to say a underwater missile is like, it's not like we can take an underwater missile and put it into any submarine.
No,
They are married to each other.
they are married to each other.
They are married to each other.
All over the world, that is the philosophy followed.
Okay. So when you are designing the missile, you are also designing the submarine together. That is what I understand. And
Not me, because submarine is another laboratory that was given to another laboratory. We
yeah,
both
no, when I'm saying you
yeah.
means when people do it, they have to think of it.
Yes. They have to sync together.
Now, secondly, you're saying that this technology is not transferred from one country to another, and so you people have to develop that from scratch on your own.
Yes.
Oh,
We
that's a
also
hard.
did, we have also learned actually some of the tests we failed, some of partially, some are fully, some
So,
ground tests were failures, but we learned and we kept moving on.
tell me, for our curiosity and understanding, how these tests are done. They are done in a small setup first, simulated tests. What do you do?
See, generally what happens, any missile system, it's a long body you see as a rocket, kind of a rocket. It consists of the number of sections. Then every section has its own number of systems. So say like again one is the propulsion system, control system, navigation system, then airframe system, then aerodynamic systems. All these systems parts are fabricated and tested at the part level.
Okay.
Once the parts are qualified, then we assemble the system as a whole.
As a whole?
As a whole means not the whole missile.
But prototypes?
One prototype of a small system.
Okay.
There are say like 50 systems in a missile. So I'm talking about each system has to be fabricated, assembled after the parts are qualified.
Okay.
Then system as a whole has to be qualified. And then after the system, it is a qualification. It is put into the airframe. That one section is that is called that one section you have made of a missile. Like you have to prepare all the section. All this section also will go for the testing. Like they will go for thermal testing. They will go for the high altitude testing. They will go for the vibration testing. They will go for the rain testing. So like that, various tests are there. They are all called environmental testing. Whatever environments a flying object face on board, that facility has to be created on the ground, and as a system, it has to be tested. Then only it is qualified for the onboard application. That is the process.
So the number of systems that you are naming and the number of tests that you are naming, that itself tells us that it must be very complicated thing where so many experts are involved, working together.
Like what happens, like the DRDO is divided into number of clusters of engineering, various tasks are given to different laboratories. Each laboratory also is divided system wise.
Okay.
So like there is one work center, that is integration, where I worked. Who will receive the system from everybody, put them together and test the system as a whole or section as a whole, and then missile as a whole.
Okay.
Like that, similarly, there will be different work centers. Like there will be one control center sector, control system center. They will, they have expertise in design, development, testing, fabrication, assembly of the control system. Another is navigation system, another is propulsion system. So like that, all systems come to the integration center, then they are integrated. We move it to the launch pad and assemble there and carry out the launch.
So, sir, now again, surface to surface missile has a different dynamics. When the liquid underwater has, there are different laws which are working underwater for the motion, viscosity, and a lot of other things. So, so you have to learn everything again.
Yeah, actually, our laboratory is, is split into different work centers, and each work center has been assigned a specific task. They carry out those tasks, and then all the tasks put together are presented to a forum.
Okay.
They are the different level of forums. They are the review forums. They review the design, they review the test results, then only they clear it for the testing and further assembly. So like that it goes on.
So tell me, like when you do the testing, you do the launching, you had to go into a submarine?
We submarine came much later stage because before the submarine came into the picture, we had to carry out the test from a dummy submarine.
Okay.
Dummy submarine is a kind of a platform. It's a static platform which is not moving like a submarine.
Okay.
But it
But
can
it
be
is under one.
it can be submerged into the water.
Okay.
At the designated depth where from the missile has to be launched. And it can be brought up on the surface also. So for the assembly of the missile, we have to go there. We have to carry out some tests. We have to do some launch preparation. We have to go to sea. And for supporting all these operations, DRDO has got its own one of the ship, Sagar Dhoni.
Okay.
So that ship also goes. Plus, the Navy supports us. Navy's 2-3 ships at that time go. So people go in those different ships. So the people who are having different assignments will be positioned in the different as a team into the different ships. Those all ships will be creating a formation around that pontoon. Then it's a drill by itself.
Yeah, it's a big exercise. Well,
Yeah.
I'm hearing this. So it's like
Drill itself, which goes on for about 3 days minimum to a week on the sea.
Okay.
Then we carry out the launch. Then we come back from there.
Sir, you are a fortunate guy. You are a
Yeah.
lucky one who has gone through all this. And we are also lucky that we are hearing this, the insider view, because we only saw the missiles on the TV screen,
Yeah.
making that zoom sound. But you have created those things, you have launched those things.
We get the support from Navy. So like once upon a time, it so happened from the ship to the pontoon, I was supposed to go there with my small 2-person team. So it is like a few 100 meters, 500 meters away. But 500 meters away, how to go from one surface to another surface? So there used to be a Gemini boat.
Okay.
Gemini boat will be operated by the Navy person. and even I don't know the swimming also. But there will be person to
Okay.
grab you, put you onto the pontoon, so you carry out that task. So it's a big teamwork.
Big teamwork. So it's not just DRDO laboratories are working
Yeah,
together. It's also
yeah. It is
Navy
the forces also work with along with us.
along with us. Okay.
Yes,
And
a Navy
so
team was also joined along with us.
yeah, so this must be a really different kind of experience from Agni.
Yes, yes.
From
It was
Agni,
a
because
totally different kind of experience,
uh,
and it is a very satisfying experience in the sense that I have been associated with this project during half of my career span,
okay.
and right from the concept inception, ab initio stage to the final stage, and it
Hmm.
has been today I feel happy that our own indigenous system has
Hmm.
been deployed our on our own submarine. It is
Hmm.
INS Arihanta,
Hmm.
and I happen to be the part of the user training team
Yeah.
to the captain of the INS,
क्या
first
बात
captain of the INS Arihanta.
क्या बात है.
And India could achieve the nuclear triad, became
Hmm.
fourth country in the world by doing so.
Superb, sir. Superb. मतलब, and we are happy that you are our senior, our alumni. बहुत
See,
graceful.
that gives the pleasure. Sometime maybe certain things I might have lost in my personal life. Maybe I would have not gained the promotion on time, or I lost or missed some promotion. But there are certain things which give you pleasure, that what you did in the life,
Hmm.
what when you are working, whether that system has come to the shape, it has gone to the forces. Now our own vessels is
Hmm.
sailing into the seas, high
Yeah.
and low, here and there, and defending our country.
So you contributed to the country, sir. In a
Yeah,
sense, you contributed to the
that gives the
country,
immense pleasure.
and that is bigger than many promotions, many increments.
Anything in the life, right, right.
You might have lost some traveling with your family, but now
Yes,
what you did became a kind of a springboard where now much higher achievements will be done by our scientists, I'm sure. So this was underwater,
this was underwater.
and you were also associated with NAG in some way.
Yeah, actually, I was associated along with the almost all the projects of the IGMDP. Those days,
Hmm.
IGMDP was having 5 projects:
Hmm.
Agni, Prithvi, Tishul, Nag, and Akash.
Hmm.
So I was associated with almost all the projects,
Hmm.
and except Tishul, all the projects have been culminated into the success finally.
Hmm.
But
Hmm.
more of my contribution towards the Agni, then this underwater project, which came at a much later stage, in
Hmm.
between now.
Okay.
Between and that is another type of challenge to work in a Nag,
Hmm.
because Agni is a 20-meter long vehicle,
Hmm.
a 20-ton vehicle, and it's a surface to surface ICBM class of
Hmm.
missile.
Hmm.
So when you are I told you that missile is made of number of cylindrical section,
Yeah. Yeah. Yeah.
and then you have to put say like in the watch we put the gear, then key, then
Hmm. Hmm.
so you have got a limited space,
Hmm.
so small components you have to make. But Agni, that luxury was there, that it's a bigger missile, so your
Hmm.
component can be bigger. But when you come down to Nag, it's a 40 kg missile. It's
Only
hardly
40 kg. Yeah.
only
When we are talking about tons and tons, and this is
yeah.
40 kg. Okay.
This is 40 kg, 2 meter,
Uh,
4 kilometer range, and it's a specific missile for the anti-tank.
hmm. Hmm.
See, it is called ATGM, anti-tank guided missile,
Okay. Hmm.
and it was the third generation missile, because
Hmm.
till that time we never had any third generation missile. Third generation missile, why it is called?
Hmm.
The first generation missile, what happens? The missile is launched from a platform, and the gun, a small platform launcher that is called. and a gunner who fires the missile, he will have a spool side wide on the
Okay.
launcher,
Hmm.
on which the wire is wrapped around, and that
Okay.
another end of the wire is connected to the missile.
Okay. Hmm.
So what happens to finally guide the missile? He moves this spool.
Okay.
Means, suppose if the missile is not going towards the target, he can move it within certain range. That is
Okay.
called first generation. Similarly, there
Okay.
is a second generation that optical systems came.
Okay.
So the spool has replaced by the optical system.
Hmm.
Wire is still there, but
Hmm.
optical system adds to the gunner
Okay.
sight, and he
Okay.
guides the missile. In the
Okay.
third generation missile, there is no connection between the missile and the gunner. Once it is launched, it is launched.
Okay. Hmm.
So that is called third generation missile, and it's a fire and forget type of missile.
Okay.
Fire and forget type of the missile means once you fire,
You
and
can't do
before
anything.
firing, you are ensuring that it is locked onto the target.
Okay. Hmm.
So once it is locked onto the target, you forget it. It
Hmm.
will either hit it, based upon
Oh,
its reliability, 99.99% it will hit.
hmm.
There may be a chance that it may miss the target if suppose tank also has moved away or there is
Hmm.
some error.
Hmm.
So this is the latest generation missile. It is possible with the uh, called a seeker head.
Okay. Hmm.
Seeker head, there is a specific transducer used.
Hmm.
So like we transducer is a component or as a engineering system
Hmm.
which senses one type of energy
Hmm.
and delivers the result into another type of energy.
Can you give some
That's why
example?
transducer.
Can you give some example for us lay people?
Yeah, I am telling that
Yeah.
transducer means here a focal plenary array,
Uh,
FPA, and charge coupled device, CCD.
hmm.
These two are the sensors.
Hmm.
What they do actually in the battlefield environment,
Hmm.
see, like you are 2-3 kilometers away from your enemy.
Hmm.
And what happens, every body, say like tank is running or
Hmm.
silent,
Hmm.
it will have its own heat radiation thermal signature.
Okay. Okay. Yeah.
If it is running, then it will have one type. Even if it is stopped, because it has run for some time, still it is emitting certain heat signature.
Yeah. Yeah.
So this is the sensor which senses that heat signature
Oh.
and then converts into a pixel image.
Okay. Okay.
Those pixel image are then taken as a on a screen
The
in the
target.
missile
Hmm.
computer that
Hmm.
form a image that tells, okay, it is something like a tank. The something is
Hmm.
projecting like that, and this thing, the tank is
Hmm.
moving or is stationary.
Hmm. Hmm.
Then slowly, when you are acquiring more and more signal, your
Hmm.
image gets
More precise.
that time you what you do, you lock on
Hmm.
the missile and
Hmm.
then you fire it. So it's a complex technology
Hmm.
which was being worked by various other countries like Israel,
Hmm.
France, and we also had certain constants. These
Hmm.
sensors are not available in our country.
Hmm. Hmm.
So, like various chips, like computers, laptops.
Hmm.
Laptops now we are assembling in our country, but
Hmm.
still chips, the motherboard chips,
Hmm.
that we don't have.
Yeah.
We we have to import from some of the industries.
I think
Uh,
there's the area where India needs to do a lot of work.
so now it has been taken up. See what happens actually. This kind of things, these are called electronic devices.
Hmm.
You require a very large foundry for that,
Hmm. Hmm.
and putting a foundry, it's a huge investment,
Hmm.
very huge investment. After that, you should have design. We can
Hmm.
have design, we can fabric, we can do the design, planning, everything, but producing in that foundry and then calibrating the foundry and then calibrating the components, then
Hmm.
qualifying the components,
Hmm.
that's what we didn't have. which now Government of India has taken up, and so we'll in future we have that only. That was the biggest challenge in the Nag missile, and then a small propulsion system, a small control surfaces, wings, assembly of that, and it has to be launched from a launch tube. See, missile, it's a missile body. It is having a control surface. This control surface you have to fold, put into a long tube. That is called the launch tube. That launch tube, along with the missile, has to be put on the turret of the tank, on the top of the tank. And through the umbilical connectors of the missile, the inside gunner and the captain of the tank, the commander of the tank, both will have the image. So they will decide in the battlefield. And I have worked right from the design, again, ab initio stage for this project. Now, luckily, see, this was a very complex technology, and it was coined during Dr. Kalam time. Though some people blamed the DRDO that the DRDO has taken long time. But anywhere else in the world also, this kind of systems have not come out in less than 15 to 20 years.
Yeah.
And we had to work under various constants. That's why we have also taken some time. But now I'm happy that recently the NAG production has started. And it has gone to the user.
Great. And
it is bullseye.
Now, I think Indian missiles are one of the top in the world right now. The kind of territory they cover, and I think जल क्या बोलते हैं जल पृथ्वी आकाश सब जगह we are covering all three aspects of it.
Now we have come to a stage that generally, Government of India carry out one exercise that they prepare a list of negative items. Negative items means they carry out an exercise for every department, every ministry, that we have to be self-reliant and these things will not import. So that's why now the missiles and various systems have been put into the negative list, means it will not be imported at all.
Yeah.
We have come to almost that stage. Still, we have to come out, come a long way for the, see, we are much better in strategic systems as on today. Then our Akash system has been, praised number of times by the Army and Air Force. Both are using it, and they what they did actually, they have in a different battlefield exercises they carry out in on the borders at Rajasthan or somewhere else on the sea. They have carried out certain exercises by firing the old missiles which are imported from their inventory and Akash missile, and then compare the result. They said Akash is performing much better.
Super.
So now only thing we have to come out that, as I said, that we have to come long way in the production and development of the tactical weapons, production at a large scale. Because what happens is strategic missile like Agni or big missiles, any country, you don't need in hundreds of thousands. You need very few. But battle is fought with the, nowadays the scenery is changed. Battle will be fought with a tactical weapon system, either defensive or offensive. On the end only, you will be using a strategic weapon system. So you need tactical weapon systems in a big quantity, in a larger quantity, in a reliable, as a reliable product, as a product to compete with the world standards, and not only fulfill our own requirement, our armed forces, but start exporting it. So that stage is yet to come. Some of our industries are gearing up for the production. They are in line. It is going on.
Yeah, I think some good news is coming now. At this stage in India, I think there are many startups are also coming up. Entrepreneurs are coming. Recently, I heard about some startup which did 3D engine for launching a rocket. They did it privately.
Yes, yes. I was not getting the name.
Cosmo
That's
Cool or something.
Cosmo, and then this is Agnikul.
Agnikul, yeah, Agnikul. So,
Agnikul has come out with its own Agni equivalent or kind of systems,
uh,
and with the new technology. What they're doing now, they are 3D printing the
3D printing.
engine, engine and propulsion systems. They are doing 3D printing, so that
So
on a mass scale you can produce more.
that's what I'm saying.
And
Now,
yeah,
our startups, if they join
yes,
this
yeah.
movement,
So our startups have come to that stage,
yeah,
and their mission is to carry out the launch of small satellites
yeah.
into the low Earth orbit.
So, sir, I think we are on a stage where we can really go very high with all the learning of DRDO for so many years, uh, and this new energy from entrepreneurs, and even now our private industry has also grown. The kind of scalability that they are doing, I think they can help us, especially for example in telecommunications. We have seen in data, we have seen it is making a
Yes,
huge difference to the
yeah,
whole country.
yeah.
And
In the missiles, and not only in the missiles, along with the missiles, there are very other systems which are used by the defense armed forces.
mm,
So, like communication equipments, radars are there.
mm,
Then even DRDO works for the life sciences.
mm,
The food required for the
mm,
Antarctica, or food required at the Siachen, or
mm,
the food required in the space capsule.
mm.
So that also we are working, and number of sectors are coming up along with us. Many startups have come. Not only big industries. Big industries have already established, and they are doing now independent job. And
So
startups also have come. A big industrial base has come up in Hyderabad, Bangalore,
mm.
Coimbatore, Pune. And
so
that's
I
why
was
I said now that DRDO has come to a stage that 7 projects they have given it to private sector.
प्राइवेट सेक्टर, क्या बात है. तो सर मुझे ये बताइए कि सो you you develop technology for defense systems, but many of these technologies and their spin-offs must be used by private sector in other kind of products.
Yeah, it is there. See, number one, see, we have a corporate headquarter at Delhi,
Mm,
and under which every lab works.
mm,
Then every lab also has got its own planning and technology
mm,
transfer group.
mm,
So once the technology is developed, this technology transfer is carried out uh, as per the certain rules and policy of the government
mm.
through headquarter, and by assigning number of parameters are there for that as per the technology transfer norms. That is one thing.
Mm.
And what you asked, another thing, that is, I forgot
Is,
what is that?
spin-offs from.
Spin-offs.
Mm,
There are certain spin-offs we have come up. Say
mm,
like we earlier days the rocket motors were using the material, steel, some kind
okay.
of steel alloys,
Mm,
managing alloys or some
mm,
other steels which are light in weight
mm,
and having high strength.
mm, mm,
So nowadays the new materials have come up, like
mm,
carbon fiber,
mm,
Kevlar fiber, composite materials.
mm.
And during Dr. Kalam time only, our one of our work centers who was working in this field, they have developed the calipers made out of the carbon fiber,
Okay.
which are very lightweight.
Mm, mm,
And this technology was transferred as a spin-off to some of the medical industry.
Medical industry. Okay.
Then, those days, if you have heard, there was a very famous uh, cardiologist in Hyderabad, Dr. Raju, and Dr. Kalam. Together, they worked and developed a stent with low cost
Okay.
for cardiac application. It was Kalam. It was name was given Kalam Raju stent.
Acha.
Yeah.
Okay.
So that was another spin-off. And I will talk about one more spin-off. Our people work, for the software, hardware, both. See, every missile is having its own onboard computer. Onboard computer is nothing but just like our laptop or what,
Programmed.
Program. So, but that program is nothing but a software which has to be generated. So those program scientists, they developed a software for the pacemaker.
Okay.
So that was transferred as a spin-off. These three I remember, which
but there must be many.
from
There must be many, I'm sure.
Yeah, there are many.
So-
See, like recently one I tell you that bio digester toilets,
Okay.
which is one of our sister laboratory has developed. It is being used in the Indian Railways.
Okay. Okay, yeah, I think it is used also now.
Yes.
So, sir, tell me one thing now, on a very practical note, if there are entrepreneurs or engineers who are listening to this and who would like to join hands with DRDO for some kind of technology transfer or collaboration, how should they go there? What is the method?
See, it depends. See, I tell you like this. First, I'll just explain very briefly what is DRDO. I mean, how it works. DRDO is a organization along with which is having around now 50 plus laboratories. Out of 5 is young scientist laboratories. So all these laboratories are put under 6 clusters.
Okay.
The 6 technology clusters are divided under the DRDO. Say like one is missile cluster. So the laboratories which are working on the technologies related to missile, they are put under the missile cluster. Similarly, life sciences cluster. Similarly, that NBC, nuclear, biochemical warfare, or other kind of things. Then other is like your arms and ammunition is one thing. Then materials.
Yeah.
Naval science and materials.
Okay.
So like our people have developed this thing, what you call bulletproof jacket out of the Kevlar, which is light in weight. It has been tested and given to the Jawans.
Okay.
We have developed even the tents for our soldiers who are situated at a glacier in Siachen.
Yeah.
So industry has to decide that which field they are.
Okay.
Whether they are like if they want to join with the missile cluster, or they want to join with their work field is say life sciences, or their work field is something else. So according to that, the tenders are published, and they can participate in the tendering, or they can give their introduction to the concerning lab director, project director, that we have this facility. You include us as a vendor.
So they can approach them.
Yes, they can approach.
Okay.
As I told you, depending upon the field, the particular laboratory you can approach, and every laboratory is having its list of vendors.
Okay.
See, like those vendors are qualified, audited as per our norms. What are the facilities they are having? What are their capabilities? What they can do really? Then, based upon that, we keep involving them.
Okay.
So like that, they can come forward. They can see. They have to market.
Yeah, they have
First,
to prove. They have to prove. They have to
no.
convince you.
First, they have to market what they have and what is their capability.
Yeah.
So for that, they have to come, meet our scientists, project directors, lab directors, tell us. And it happens when I took up in my later part of career as an administrative role. Various industries come forward. We listen to them. We ask them to give a presentation that what are the equipment, machinery you have, what are your capabilities, whether you have design capabilities or manufacturing capabilities or testing capabilities, you know, and to what scale you have, means how big components you can do it. Then we see that, and then what we do, we visit that industry, we align them with our concerning scientists. Those scientists start visiting that industry, then slowly they involve him in tendering and by giving the small scale work, and like that actually many industries have come up in Hyderabad.
Yeah, I think that's fantastic, sir. And your laboratories are not just in Hyderabad; they are all over the country. I
All
see.
over the country.
So it's not that you have to be in Hyderabad. It's a
Many
fantastic.
industries have been introduced in Bangalore.
Pune also has some facilities, I think.
Yeah, Pune also.
Okay. So, sir, you have given us a very good broad understanding. We also got a sense that what it takes to make this kind of missiles. There is one question I don't know whether we can take it now at this juncture, which is what will be the role of AI in warfare? I think that's a huge thing. But if you want to spend a minute or two, uh,
Oh, sure. It's a hot topic nowadays.
uh,
And when I was in my later fag of the career, working as a associate director of the DRDL, and my director was Dr. Dasharath Ram Yadav. We decided and coined a separate artificial intelligence group
okay.
in our laboratory.
Hmm.
Generally, what happens in missiles, how to incorporate artificial intelligence. Say, like, one example, as I told you, that third generation missile now means it has got a fire and forget capability. After seeing the soldier, once sees the one target, he lock on one missile and fires on that, and then he moves on to the another target. He not to bother. So how we are achieving it? It is by certain programs,
Yeah.
certain sensors, certain hardwares. So certain hardwares and certain softwares are always part of the artificial intelligence. Those things we have to develop and incorporate in our missile systems. In our missile laboratory, there is a group called system engineering. This system engineering team, what they do, they take the data of all the data they take from various groups. Say like control system group, they take the data like what is the control specification of a particular missile, means how much I can maneuver the missile without affecting its performance, and then how much time it will take to maneuver once the command is given and the followed. That also matters. Then navigation. See, what will be the navigational errors? So system engineering group, he takes the data of all the systems and runs the missile trajectory on a computer.
Okay.
And then devise the trajectory for that particular missile is the optimum trajectory which should be followed by the missile to hit the target with that much fuel.
Yeah.
In that much time as required as per the specification of. So these things now, what we are doing, these are called algorithms,
Yeah.
missile algorithms. So we are incorporating, various software updates and programs in terms of various applications which will later on come up as artificial intelligence. That way, it will be implemented into our systems.
Okay. So great, sir. It was great talking to you. You really took us through the whole journey, your journey, the journey of development of DRDO. I am getting greedy. I have a lot of questions even now. Uh, but this system also has certain constants. Uh,
Yes.
we have set it up for certain time. So I would ask one question because we are talking and many students would also listen to it. Uh, what do you think? They should go to DRDO as a career? You think it is exciting?
For the which sector, missiles or for the defense?
In general, I'm saying students generally they don't think about DRDO or ISRO. ISRO is in news right now, much more than DRDO. So I'm saying in these kind of sectors, what are the I would say what they get out of it apart from the private sector can give money, perhaps more money. Uh, but what DRDO can offer to students?
Yeah, I can tell. Number one, as I said, DRDO is working for the vast field of
Hmm.
technology and sciences.
Hmm.
As I told you that all kind of sciences, engineering fields are available here.
Hmm.
A person qualified with the background or educational qualification in physics, chemistry, maths, chemical engineer, mechanical engineer,
Hmm.
even civil engineers
Hmm.
who are later on become expert in the structural design.
Hmm. Hmm.
So then instrumentation or say propulsion, safety, and so on. There is a scope for everyone here.
Okay.
That is one thing. And DRDO also has become very popular since the time I joined. In fact, that time nobody was knowing,
Yeah.
and now many people know it. And it has delivered number of good systems to the armed forces.
Hmm.
It is into the limelight, and I tell you, here the work culture is very good.
Yeah.
That I found in my laboratory means, in fact, those days you can go anytime and come anytime.
Hmm.
Nowadays, the Aadhaar-based attendance has come.
Hmm. Hmm.
You have to go only as per the fixed time,
Hmm.
but you can come out from the office anytime.
Okay.
And it is up to your wish and will. If you want to work on Saturday, Sunday, you work.
Okay.
Nobody will stop you.
Hmm.
There is no crunch of the resources.
Hmm.
If you want to buy, if you want to get trained, you yourself, think of a course
Okay.
and find out the institute which can give you the training.
Hmm. Hmm. Hmm.
Or even there is a program for further, qualification upgrade, MTech, PhD.
Hmm. Hmm.
And
Hmm.
apart from that, there are number of conferences, technical conferences, workshops, wherever you
Hmm.
want to participate, you want to publish a paper. Only thing, as per the government norms, you have to take government permission.
Hmm.
But nobody is stopping you
Hmm.
for doing a good work. The person who is interested in work in any field of science and engineering, he
Hmm.
gets the opportunity to work
That's
without
super.
without any hassles, and he can come up by his virtues. That
क्या
is the
बात
wonderful thing about the culture and this thing here. And now, in fact, we have got very good resources.
Hmm.
We have got very good infrastructure
Hmm.
for everyone, and we have got digital libraries. We got almost every facility. Even every scientist is given a update allowance here.
Hmm. Hmm.
As per his rank, he has been given yearly update allowance, where he can become the member of various societies.
So in a sense, anybody who wants to learn, who want to grow, this is a great place to be.
Yes.
So thank you, sir, so much. दो चीजें बोलूंगा, एक तो आपके पिताजी का एक सपना था कि बेटा आर्म फोर्सेस में जाए, तो आई थिंक एक अकेला बंदा वहां पे बंदूक लेके खड़ा होता, उससे कहीं ज्यादा डिफेंस आपने देश के लिए कर दिया है. एंड दूसरी बात मैं कहना चाहूंगा कि इफ गेसवाइट्स would like to talk to you sometime, can I share your number?
Oh, yes.
Contacts with?
Why not? Sure, please.
Because
And
many of them,
most welcome anytime anybody wants to contact me.
And if the college wants you in some
100%,
capacity.
100%.
Thank you, sir.
I'll be delighted. Thank you very much, Puneet ji.
Sorry, sir. Sir,
And,
it was a great
so kind of you
experience.
that you have given me a wonderful opportunity. Thank you.
Sir, we are privileged to have you, sir. And,
thank you very much.
So on that note, Jai Hind, Jai Bharat. फिर मिलेंगे हम. And आपकी परमिशन से मैं यहाँ पर एक विराम लेता हूँ.
जय हिंद.
तो दोस्तों फिर मिलेंगे अगले सेशन में, फिर किसी शानदार पर्सनालिटी के साथ. शब्बा खैर.